This is Joe, Assistant Professor from Department of Physics in this College of Arts and Science, Cuddalore. So we can see the fiber joints and couplers, which is used in fiber optic communication system. This is a fundamental diagram which gives information what is transmitter and what is receiver. And in transmitter we have channel coupler, carrier source and modulator. The carrier source has to be joined with the coupler, and it is modulated where it is transmitted, and it is carried out through the optical fiber, which has the repeaters or amplifiers which joins, and when the receiver end the detection has to be carried out by the optical detector in terms of optical lens. And next to that it is the output of the optical detector. It is given to the amplifier. The signals are amplified and it is processed and it is given to the output. As fiber joins, the optical fiber links with an line communication system which have requirement for both jointing and termination. The fiber joints has to be a very important parameter, very important feature, which has to be a less attenuation factor. And single mode fiber has continuous perform length around of 200 kilometers. Single mode, as we see earlier, a single mode has a single information signal has to be carried out, but it has a length of 200 kilometers through a fiber span that cannot be installed. So 200 kilometers, we can't use a single mode without these joints. Then why we need fibers is up to 2 kilometers we can have a optical fiber. So for longer spans a joint is needed. If it is damaged, we can easily cut it out, and damage can be rectified by using these types of joints. All the fiber cable cannot be installed as a continuous cable. As you know that it is difficult, joints are needed. So what is, if we install a joint for a fiber cable, definitely there may be a loss in it. So what are those losses is, in fiber communication there is definitely optical loss which is encountered at interface. If it is two fiber optical fibers or joint, so definitely there will be a loss at the interface. It means spiling, even though we spile it, there is a loss, attenuation happens over there at the interface. The loss in optical fiber through the connection is defined as, and you know, PO is the output bar and PI is the input bar, which is connected to the source fiber and the fiber at the output, and these are affected by intrinsic and extrinsic coupling losses. Definitely the intrinsic losses is occurred by the internal parameters, and extrinsic coupling due to the environmental factors also influences the losses, optical losses at the interfaces. So intrinsic losses are caused by inherent fiber characteristics. If two fibers are joined and there may be a slight distortion in the refractive indices of the source cable fiber and the joint, so there will be a optical losses over there at the interface. So it is categorized as intrinsic coupling losses, and extrinsic coupling losses are caused by jointing techniques. Different filing are used to joint the optical cables, and the losses happens due to those conditions are called as extrinsic coupling losses. So intrinsic coupling losses are limited by reducing fiber mismatches. We can reduce this type of intrinsic coupling by using the same to the maximum extent. If we use a same refractive indices or different fibers used for a coupling joint, we can reduce intrinsic coupling. This is done by procuring only fibers to make the geometrical, which has the numerical aperture, geometrical specifications, and several parameters which has to be considered in fiber joints. If we consider all those parameters, we can definitely reduce the intrinsic coupling. And next one is extrinsic coupling losses are limited by proper connection procedure. There are several procedures which we can follow, and due to following we can definitely reduce the extrinsic coupling losses. When optical fibers are connected, optical power may be reflected back into the source fiber. Light is reflected back into the source fiber, and this reflection losses is termed as Fresnel losses. Occurs in every fiber interface. In every fiber interface, if a joint has to be there, definitely there will be a Fresnel losses when light is reflected back into the source fiber. Fresnel reflections is caused by step change in the refractive index that occurs at the fiber joint. When a fiber is joined by using a spiling technique, change in the refractive index causes these losses. Light get reflects back, and this is termed as Fresnel reflection or Fresnel losses. How to reduce these things? To reduce the amount of loss from Fresnel reflection, the air gap can be filled with an index matching gel, and by using a gel type of fluid, we can reduce the Fresnel reflection losses, which reduces the air gap. The refractive index of this matching gel should match the refractive index of the fiber core, which also we have to consider the refractive index of that index matching gel too. Index matching gel reduces the step change in the refractive index at the fiber interface. So it reduces the change in the refractive index at the interface, so we can reduce the losses. Misalignment losses. This is an important another losses which quite happens. These losses depends upon the fiber type, core diameter, and distribution of the optical power. So misalignment losses, if the alignment in the joints are mismatched, so these losses occur. The core of the diameter of the core and the numerical aperture is taken into consideration to reduce the misalignment losses. And finally, fiber spirals, a permanent joint formed between two individual optical fibers. And this is important parameter. There are types of fiber spirals, and fiber spirals means joining of two optical fibers, which is termed as a permanent joint. To establish, there are types, and we can see the two main classification. One is fusion spiraling and another one is mechanical spiraling.